In this video, we're going to review the overall project structure so that any programmer can take it from here and develop their own custom solution to create digital twin offices. First, let's select the project scene located in this folder. The project scene contains all the controllers that manage the application. Everything is optimized to run in the restrictive environment of the browser, and instances of the necessary resources are only created when needed, avoiding unnecessary CPU overload. Before diving into the project, let's review the main libraries used in this project. The User Management Library handles user login and registration operations. It currently supports two backend types, PHP endpoints with MySQL and Firebase. The code structure is designed to support different backend technologies. The AI library provides the basic functionality for AI operations, in this case through a backend running Python scripts. The networking library is intended for implementing multiplayer features. There are some references to this library in the project in case you decide to enable multiplayer functionality later, but it is not currently in use. The Utilities library offers a collection of common tools typically used in this kind of project. The VR library provides tools for creating virtual reality applications. There are also some references to this library for potential VR support, but it's not currently being used. Before going into the code, let's review the assets included in the project's asset bundle. All of these assets are basic geometric shapes, such as capsules representing avatars or various cubic shapes for building the office. They are sufficient for running the simulation. Now, let's review the resources included in the build. Here is the file containing the application's text. As you can see, it uses an XML structure to define the correct text for each language. The file named prompts follows the same structure as the language file but is kept separate because each developer will need to customize it for their specific use cases. Let's review one prompt as an example. This is the prompt used for analyzing a candidate's test results. Prompts include a special symbol that is replaced by the XML tag corresponding to the selected language. This approach allows us to modify the XML structure without having to rewrite entire sentences. Continuing with the resources, let's review the screens that appear in the main menu section of the application. For example, Screen Main Menu View is the main menu screen, acting as the initial hub for basic operations. The Settings folder, we can find screens related to login and registration, as well as the screen used to set up the API keys for the LLMs you want to use. The Edit Options folder, we can find screens for creating and editing new offices. In the Information folder, we have a collection of general-purpose information screens ready to be adapted for any need. Next, we'll check the screens used during the simulation. The most critical one is the Time HUD, which serves as the central operations hub during simulation. Calendar screen displays both meetings and the progress made by employees during the sprint. Meeting screen shows all the necessary details of the selected meeting. Task Manager screen, inspired by traditional sprint boards, includes the usual sections for classifying tasks based on their progress. Task screen provides detailed information about a selected task. Projects screen allows you to organize the various projects being managed in the simulation. In the AI folder, we have a collection of screens used in the final step before sending prompts to the LLM. The most important screen here allows us, through a set of toggles, to customize the amount of information included in the prompt. In the Addition folder, we can find the lateral panel used during the office building process. Now we can start reviewing the project's specific code. This project is based on the Model View Controller MVC design pattern. Before explaining the code, let's look at the scripts that run on the backend. In the Database folder, we have the SQL database containing the data structure and sample data needed for the initial installation. In the PHP folder, we have all the backend endpoint scripts related to project data management. In the Python folder, we have all the backend endpoint scripts related to AI processing operations. Let's start with the scripts responsible for data management. The main script that handles all project data is Workday data. This script safely reads and stores project information and includes all the endpoints required for the front end to communicate with the backend. In this folder, we can also find scripts that send requests to the backend for AI operations and process their responses. If we open any of these files, we'll see a consistent structure, a URL field containing the endpoint to be called, a build function that constructs the HTTP request, a response method that handles the backend's reply and sends it back to the application. In the database folder, we find a similar structure, but these scripts manage the project's data instead of AI operations. In the project folder, we define the data types used by the system to organize information. The most important is project data, which represents the main data structure containing the entire project. Now let's move on to the scripts in the controller folder. We'll start with Application Controller, the entry point where all controllers are initialized. Command Controller manages all command patterns related to AI operations. Checkout Controller serves as the interface with the NetCheckout asset and handles the slot purchase process. Clock Controller manages the clock, checking for meeting triggers and other time-sensitive operations, such as entering or leaving the office. Command Controller handles command patterns for non-AI operations, such as moving avatars around the 3D layout or navigating to meeting rooms. Document Controller manages documents, so the system can use them as a basis for creating tasks and meetings. Image Database Controller manages images used by the system. Designers can upload visual designs, which the AI can then analyze. Level Edition Controller manages the editing operations for the 3D office layout. Meeting Controller handles all aspects of meetings, from start to conclusion. Prompt Controller reads the text containing prompts and provides access to each individual entry. Finally, Tasks Controller manages the entire task lifecycle, from creation to completion. In this folder, we can also find all the AI command patterns used in the system. Each command pattern is a logical unit containing the necessary logic to create a prompt and format the response in a way that the system can process. In these command scripts, there is always a request method responsible for creating the prompt, and an event handler that processes the backend's response in the correct format. In another folder, we have commands not related to LLM operations, for example, commands that move avatars to specific positions. In the States folder, we define the state patterns that the application transitions through to complete the simulation successfully. For example, this script handles the running stage of the project simulation. Now let's move on to the visual components. We'll start with the most critical one, the time HUD, which the user uses to access all available simulation functionalities. In this script, you can see references to visual elements like buttons and toggles, which trigger actions dispatched to the controller for processing. Another critical script is the calendar, which contains all the links to its visual elements so users can properly organize their time schedules. In short, all components in the View folder handle user input, send it to the controller for processing, and display the final results. Before running the simulation, let's take a look at the backend scripts used for AI LLM operations. If we open the English server, we can see an instance of this class which defines all the endpoints available for the front end to use. Let's open this script. Here you can see how the backend endpoints are defined. So, we've completed this introduction to the project structure. Now you have all the information you need to branch this project and create your own digital twin office in no time. In other videos, you'll learn the first steps for installation, as well as how to use your digital twin office to simulate workflows or evaluate job candidates.